Hello everyone, today we will discuss about Bernoulli's equation and its application and some problem about it. First, Bernoulli's theorem. Bernoulli's theorem. It states that the sum of kinetic energy, potential energy and your pressure energy for a ideal steady flow for irrotational fluid remains constant. That means the sum of kinetic energy, potential energy and pressure energy for an ideal fluid remains constant. This is known as Bernoulli's theorem. Mathematically, for kinetic energy we consider V square by 2g. For potential energy, it is of your Z. For pressure energy, your P by rho g. So, sum of pressure energy, sum of kinetic energy, sum of potential energy for a ideal fluid remains constant. This is known as your what? Bernoulli's equation. This equation is derived from Euler's motion equation. What? Euler's motion equation. Generally, assumption taken for Bernoulli's equation is fluid should be real. Second one your ideal. Third one your irrotational. Flow. The fluid should be real, ideal and irrotational. Then Bernoulli's equation helps for calculating the total energy of the fluid. Generally, Bernoulli has different types of application. Some of the application are venturimeter, your orifice meter, and your third one pipette tube. Venturimeter and orifice meter we conclude or it helps for calculating the discharge. Mathematically, for Venturi meter, formula is equal to CD is equals to A1 into A2 divided by A1 square minus A2 square into 2GH whole root over. For orifice meter, CD is equals to your CD, then write down here your discharge Q is equals to A1 into A2 divided by A1 square minus A2 square into 2GS into CD. This CD represented as coefficient of discharge. Coefficient of discharge. For orifice meter, Q actual is equals to A0 into A1 divided by A1 square minus A0 square into 2GH root over into CD. For orifice meter, it becomes CV and its value is 0.9798. For Whiter tube, V is equals to 2GH root over. Okay. These are the basic application of Bernoulli's theorem. In Venturi meter, total discharge is equals to first and second term multiplication, then its subtraction, then whole total of coefficient of discharge multiply on this, then we calculate the total discharge. For orifice meter, same formula also, but we have to remember that for orifice meter there is coefficient of velocity, okay, not discharge. In Whiter tube we calculate the velocity. These are the application of Bernoulli's theorem. Then comes to some simple problem related to the Bernoulli's equation. First, here data given, water is flowing through a pipe of 5 cm diameter under a pressure of 29.43 Newton per semi square. Here velocity given, here your pressure given, and your cross section head, datum head also given. So, let us simplify this solution. Total energy equals to your sum of pressure energy plus kinetic energy plus your potential energy. Value of P here 29.43 into 10 to the power 4 converted into meter. We know that for density it is 1000 for water. G, value of G is acceleration due to gravity is known as 9.81. Then here given mean velocity of 2 meter per second. So, 2 meter per second square divided by 2 into 9.81. Your datum head is what? 5 meter. Calculating above, in a scientific calculator, we conclude the value that its value is 35.36 joule. Okay. This is the required expression. We know that what is the pressure value, what is the velocity, mean velocity and datum head, and we also know that acceleration due to gravity, the value of g, and for water we know that rho is equals to 1000 kg per meter cube. By this method we calculate the total energy. Then comes to another problem. Data given here, solution. Total energy is equals to sum of pressure energy, sum of kinetic energy and sum of potential energy. Here data given, pressure energy is equals to 10 into 10 to the power 4, we converted it into meter. Rho, value of rho is equals to 1000, value of g is equals to 9.81 plus mean velocity 5 meter per second divided by 2, your g value is 9.81, it is acceleration due to gravity. For datum head 5. By calculating it in a scientific calculator, we find the value that its value equals to 16.20 joule. These are the some problems about Bernoulli's equation and some general formula for Bernoulli's equation and some application in it. In the next topic, we will discuss about another one. Okay, thank you.